All right, folks, welcome to week 3. Uh, this week, I'm going to select like last week, we basically covered how to create objects and change them, how to add rows and how to get rid of them and change them. This week is more, I'd say it's more the meat and potatoes of SQL because the insert, update, delete is stuff you do occasionally. Select is something you do all the time. Um, a perfect example, you open up Brightspace and the content comes up. That's getting pulled with select statements out of a database. Or you go to I don't know, you go to Reddit. Those headlines are coming out of a database. So you know, so the select statement's actually fairly straightforward. Um, it's made up of many parts, and we're going to just build up on it slowly. But pretty much the rest of the semester is going to be a select statement. So just so you have an idea of how much more there is to it than just what we've been doing. So this is the equivalent to hello in SQL or from pick a table. In Python or whatever, you do a print hello world, or in JavaScript, you could do an alert or console.log or whatever and print out to wherever it's going. Usually hello world's considered the very first program a person writes. In SQL, it's select star from something. Now, to break this down, what it's actually doing is the select part of it's basically telling you, hey, I want to grab some rows. So I'm going to choose rows, or I'm going to select some rows. In this case, the asterisks, often people just say star, means all available columns. So every field in the table, I want them all. From says this is the source I want you to pull it from, and then you tell it where you want to grab it from. So if I run, first things first, let's switch to the right database. So I just want you to run it. There we go. So now we're in the world database. Now I'm going to do my select statement. And here's my pile of rows. It's nice and quick. If you look at the output, it ran in 77 milliseconds. The fetching is how long it took to transmit it. Doing select star is great development. So when you're looking at the database, you're trying to make sure things are working, select star is fine. But when you're actually writing an application and you're retrieving rows from the table, so with what you pull out. Um, and by selective, I mean, really, you should only retrieve the parts that you need. And I like using the kitchen sink as an example. So you fill your sink full of water and you just all the water disappear instantly, but all the water to go down the pipe. Why? Because the pipe only has so much volume. Select star, you're literally just pulling the plug on the bottom of the sink and you're just letting everything drain. Now, this database is small. It doesn't have a lot of rows. So let's just say a single row is 1 kilobyte. For people that are used to having cell phones, they take pictures in the 4 to 6 megabyte range or more. You think, what's 1 kilobyte? Okay, let's do that 1 kilobyte times 10 million. Suddenly, it's a big chunk. And in proper environments, that isn't a developer's laptop or developer's workstation, in other words, a real proper server room setup, the database server is almost never running on the same server as the application is. So you've got a web app, it's running on one server, the database is running on another machine. That means the data is being transferred over the network. The network is like the drain in your sink. It can only take so much traffic between two machines or across the switch or whatever is applicable. So you've got network switches that are in the 25 to 50 gigabit range. Um, not as much of consideration as it used to be, but then again, we're moving a lot more data across those pipes as it is. Therefore, that pipe gets full and the data slows down. Now, if I were to go name, comma, country code from city. Okay, so the last time I did it, it ran for 77 milliseconds. The fetch was 358 milliseconds. If I were to run this with 6 milliseconds and the fetch was 169 milliseconds. Why? Because I'm asking for a lot of stuff. The sink isn't as full. Um, Another example is if you are walking down the hallway and you've got a group of people ahead of you all walking 4 people wide and you can't get past them until you get out of the way. When you have a query that pulls a lot of data, it's like those 4 people walking down the hallway. The next query can't be run until the previous one is finished. Database servers are really good at doing things concurrently, but even they have a limit. So the bigger the query, the slower it's going to run, the longer it takes to transmit, which means it adds latency to the whole operation. So again, I select everything and it took 77 milliseconds and whatever number of milliseconds transmitted. Fantastic. Million rows, it's a lot bigger. Now let's go say we're doing 500 of those a second. And if each one is adding an extra 400 milliseconds more than it needs to, eventually that seconds and minutes. And it's system slows down as in until people stop asking questions, that delay will just keep snowballing and getting bigger and bigger and bigger because you're asking too much. But when you write queries, realistically, you want to retrieve the bare minimum to do the job. Why? It's going to run better. The database administrator won't hate you. The developer, the users are going to be happy with you because their stuff is going to run faster. The only thing that you're not going to like is the fact that you have to, be a little more precise in your code. And honestly, there's nothing. He's not a good thing. All right. So now I'm going to talk about distinct, where we can even reduce further the data. So let's say I want to just select the country code. Oops. Oh yeah, I got to mention something really quick at this point before I continue. You've noticed I'm mix matching uppercase, lowercase. The select, so the SQL part of the language is not case sensitive. Okay. Depending on your database server, the object names may or may not be. MySQL just accepts it for what it is and it'll give it to you whether you're uppercase or not. Microsoft SQL Server depends what code page it's installed in. Code page is basically what language the operating system is running on. Oracle will lie because Oracle actually stores all the object names in uppercase. So you give it whatever case you want and it changes everything to uppercase anyways. So it's saying, yeah, I'm not case sensitive, but actually it is. It's just lying. Was it? And then you have database servers like IBM or PostgreSQL. They are super case sensitive. Like they care a lot. It's case sensitive for the objects and the data. MySQL is not case sensitive, and MariaDB is not case sensitive about anything. So just you can write it uppercase, lowercase. I don't care. All right, there isn't. A lot of people like using uppercase on the SQL keywords for ease of reading. The standard is whatever your employer tells you it is. Depending where you work, some people will enforce an SQL standard, some places won't, because in the end, you're probably generating the SQL using programming code anyways. It's roughly the same. No problem. All right. So the next piece that I want to worry about before I dive into a significantly more complex part of the select statement is we have a way to say, I just want the unique rows of data to be returned. And That's the distinct keyword. So you'll notice here, the first time I ran this query, we had Afghanistan 1, 2, 3, 4 times. When I run distinct, you'll see Afghanistan only shows up once. What distinct does is it looks at the entire row. Right now I'm only returning one column, therefore the row is unique. Well, it's easier to make it unique because it only needs to look at the one column to make sure it's distinct. If you had multiple columns, when you do a distinct, it runs on the whole set of columns. So if I were to add the name of the city back in, like this, suddenly we are back to the same number we had, which was 4,056. But if I just do the distinct country code, 232. So what distinct does, it operates on the entire row that gets returned. So the more columns you add, the more distinctness you will have. And the more distinctness you will have, that means, you're not going to get necessarily as clean a list of data. Uh, where would you want to use something like distinct? Um, occasionally you'll have cases where you have the same information repeated. Um, an example that could be an email address where people register something and they register multiple times, and your takes the data and just shoves it into the table and doesn't care. And then you send out a alert. You don't want, let's say the person registered 5 times, you don't want to send this. In actual fact, you can get in trouble for that in some countries. A lot in Europe, actually. Um, some of the European laws are really pretty special on that kind of stuff. Um, so you use distinct, and it will only give you unique email addresses. In this case, I just want the list of country codes found in city. Therefore, I asked it, just give me the unique one. So I just want to know which countries have cities. Well, all countries have cities, but you know what I mean. Which countries in this case have cities? He gives me the distinct list. Just beware when you use distinct that it operates on the entire row, not on a specific column. Some actually allow you to be distinct for some columns and not others. Um, the results end up getting always a little weird because you're telling it to be distinct, then suddenly tell you don't need to be distinct at the same time. Um, so you should always assume this, you want to do the distinct for the whole row. And again, if I run this one, how fast did that just run? 4 milliseconds, and the fetch was 157. Um, so you might have noticed that I didn't get that much of a performance gain from doing this to this. Why? Retrieving rows, the distinct needs to keep track of each new value. So it reads row 1, goes, do I have this value in my bin? No. Boop. Reads row 2, is this value in my bin? Yes or no? Yes. It skips it. No, it adds it to the bin. So there's a little bit more computation happening at the top. Realistically, there isn't that much of a difference between um, one column and 2 columns of data. Therefore, the actual size coming back is kind of small. I really wish this could tell me how many K was being transmitted, but it doesn't. I'm sure I could calculate it, but there's no point. So that's the select part of the deal. You can also do one last thing with the select, and I think I actually usually cover it later, but I'll do it right now so I don't forget it. Um, and that's known as an alias. You can rename things. So you can rename your columns on the fly to something else. Um, once I start doing, what's the word I'm looking for? When I start teaching you guys about aggregate functions a bit later, the reasoning behind this will make a lot more sense. Um, but you can use this to actually have pretty columns or pretty column names like this. And now we have a pretty column name where we have a space and uppercase, you know. Um, Way back in the day, um, people ran SQL, and after they knew it worked, they wanted to run the reports. It was for their managers because language was created for managers, but obviously the managers never figured it out, so it was still the programmers that did it. They wanted their reports, so what we'd do is man, that ages me. This is how I learned how to submit my SQL work when I was in school. We had a line printer in the room, not a dot matrix printer, a line printer. They're big and they're really, really, really fast and really, really loud. And it go right as it prints. What you do is you could take this report and output it directly to the line printer. You say, take the results of this and you'd output it to the line printer. And the report would print, and you take that and take that to your boss or your manager and give them the report. They wouldn't necessarily want to see the ugly columns. They want to see the nice column names so that their brains actually understand what they're looking at. Therefore, you'd use an alias to rename the columns and make them pretty. And you could actually make this look like a proper report that went through a report engine instead of, raw code that outputs to a screen. Yeah, when I went through school, that's how we handed in all our SQL work. We had to send everything out to a line printer, and then there'd be a race to who would reach the line printer first, because if you weren't the first, you were behind everybody else and you had to wait. I wasn't, I was rarely the fastest. All right, so that's the select part of the select statement, the part where you're, picking your columns, that kind of thing. The next part is the where clause. And the first thing I got to bring up is a phrase called a predicate. That word is not going to be in the slides, just so it won't be on a test. However, when you're talking about Boolean operations in a database server for comparison purposes, it's known as a predicate. In your programming classes, eventually you'll learn about something called the if statement. Usually by week 3, you haven't done if yet. The if statement is a comparison. If a greater than 10 or I is equal to 5, that's a predicate. You're doing a Boolean operation where you're taking value, operator, value, and you're comparing them using whatever the rules are for. Yeah, good old if else. I really don't know at what speed you guys are learning this stuff. When I teach in CST and CET, they're learning Java, so they spend the first month just learning how to use Java and not jumping straight into an if statement. So a couple of you have heard about the if statement, so that's good. So you understand the concept of a predicate. That's the technical term for that, by the way. And it still applies in programming languages too, but they say, yeah, it's just, an if statement, and you're going to compare something. That comparison is actually called a predicate. So in SQL, when we want to filter which rows are being returned, we use a where clause. And the where clause is a series of predicates. So if I go select name, comma, country code from city, where country code Canadian cities. I have no idea what their criteria was when they built this database, but here are the Canadian cities. Well, at least Ottawa's in there, so that's good. Now, this part is nothing new. You've seen this elsewhere. What's happening is when it does this, it will go and say, hey, I'm going to retrieve rows from city, and it starts going through the rows, row by row, looks at the country code, and says, is the country code, in this case, equal to Canada? Yes, no. Yes, it puts it in the output buffer. No, it discards it, goes to the next row. Of course, there's ways to speed this up, but that's essentially what it's doing is row by row, it looks at the column, checks the predicate. Is it true? If this is true, in other words, country code is equal to Canada, true, it goes into the output buffer. Otherwise, it just gets discarded and it moves on. So if I were to, of course, all I showed was the equality operator, and this is the one where most programmers that are learning SQL after they've learned programming struggle? Please note, equality is a single equal sign, not two equals. You guys are going to be in Python and JavaScript. Single equal is assignment. You're assigning a value. In SQL, you're comparing. There is no equal, 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 or equal, equal. Is it equal? Single equal sign. Um, some database servers have gotten really good at accepting stuff like double equal because they realize we could do, but most will not. And as you can see, I just put in my double equal and suddenly I've got a little red underline under the double equal and there's a yellow to it saying, hey, you've got an error. So a single equal. Now I just need to double check what's in this table one more time. Good, population, fantastic. Okay, so we are going to, and I'm going to include population like such. And I'm going to go, another one we can do is population greater than or equal to 1 million. So that's basically going to give me any city where the population is more than 1 million. I could turn it around and say less than 1 million. I really should put my semicolon here. Whoa, what are you doing here? Less than 1 million. And now here's my list of cities with less than 1 million. Um, you have all the normal operators you're used to seeing. So equality, less than, greater than, less than or equal to, greater than or equal to, greater than, all the normal numerical comparisons. And realistically, less than or greater than is stuff you learn in grade school. You learn about the crocodile, right? We're just going to eat the other number. My kids are in their 20s, but I still remember doing that with them. Um, coming. So there is a few others we can do. Um, so I'm just going to go do the multiple clause one, and then I'll address the between one. So let's just say I want to have a like that. And actual fact, let me turn that around so it's a little less painful on people's brains. Like this. All right, so this is basically give me everything where the population is greater than 500,000 and less than 1 million. So therefore, we're going to get that range of 500,000 to 1 million. There, cities where the population. Oh, actually, let me turn. Let's go where country code is equal to Afghanistan and country code is equal to Canada. Okay. Manager would ask you for the data. I want to know everything in Afghanistan and in Canada. It's, it's going to give me nothing. So in other words, it's or. So it's you're in Afghanistan or in, so you have to read and then translate to what the computer wants to do. So if I run this one, that works. Now we can go a little bit further past this and we can add one last rule because of course, I'm going to put this on multiple lines because now it's getting, oh, it doesn't care about carriage returns. It cares about the semicolon. All right, so I'm going to run this and you'll notice that it didn't quite do what you think it's about to do. So it gave me in Afghanistan, but this is more than a million. Think about math and you learn, miss, brackets, exponents, blah, blah, blah. Right. So what happens is SQL will resolve the and before the or. So it does and or not. So in this case, what it did is it did this logical operation. Country in Afghanistan, in countries with, I mean, or cities in Canada with less than a million. Um, that's funny because it says Toronto is less than a million because technically the city of Toronto is less than a million. The Greater Toronto area is significantly more than a million. Um, so what you want to do is you can use parentheses to control the order of resolution. So this will say anything in Afghanistan or Canada and the population is less than a million. So if I run this, now everything's under a million, but only gives me Afghanistan and Canada. So you can use the parentheses to control the order of the operation, just like when you're learning about your if statements, right? Where if you have multiple if clauses, you can actually use parentheses in the if statement to control they get resolved. And it's just like in math. You always resolve the parentheses first, and then you take the results of that, and then you work your way out of the parentheses to the greater. It's the same thing in SQL. You resolve the parentheses first and work your way out from there. Okay. Now, he asked a question about between. Let me grab this one here. And there is a different way of writing this, which is I could use the keyword between. That will give me the exact same result as this. Between does have some interesting quirks to it. Um, between will always include the endposts, as I like to call it. In other words, when you use between, it will include 500,000 and 1 million. This one, on the other hand, will be 500,001 or 999,999. So depending on what you're trying to do, between may not do the trick for you. All right. So this particular chunk I have here, which will lead me into my next topic, in right now I have a list of values where I'm saying where the country code is Afghanistan or Canada. If I want to write this in a way that's less ambiguous for some people, because let's say two country codes, piece of cake. Let's say we have 6 or 7. This is going to start getting pretty fat pretty fast, right? We're going to have a query that long. Normally what you'd want to do is you use the in statement. And the way in works is it's a list. And I run this. It's going to be the exact same result. So what in does is it looks at each of the common delimited values and it compares them as, so it's as if you're doing an OR. So in here, if I want to add uh, BLG and CHN, maybe? I'm picking country codes at random here. There's Canada, there's China, and apparently BLG is not a country code. Okay, FRA. That one's good. I'm 90% sure FRA is good. Yeah, there we go. France. All right. So within a list, very handy. So what time is it? I'm good. So the next one I'm going to cover is pattern matching. Pattern matching can be a little rougher to learn, especially when there's a timeline, right, on learning it. Um, so let's just say city where name like. All right, so let's say we match a pattern. For example, I want to grab every city where that starts with the letter A. And essentially with the command like, we have um, two special characters. We have the percent sign. Percent sign says match 0 or more times. So if I say like a percent, it's going to say anything that starts with A, and I don't care what's after A. A could be the very last character, literally the country is called A. Or it could be Amsterdam or, Almere, or take your pick. It doesn't make a difference because the A is followed by 0 or more characters. It doesn't care. You can put the percent sign in multiple places. Let's say I want to turn this around and say, whoops, instead of starting with A, I want countries that end in A. So this is saying, any letter, I don't care as long as it ends in A. So n number of characters or none, any character as long as the last character is A. So we can turn this around and say, hey, I also want to know all the countries that start in A and end in A. I mean, countries with cities. So now we've got Annaba and, a bunch of others. And so that one's basically saying, hey, A%, A, so starts with A, ends in A. It doesn't care which way you do it. And I can be the other way around. I want to say, as long as it contains the letter A. So as long as A is anywhere, and of course, remember the percent sign stands for 0 or more. So if there's no character in front of the A, it's still going to match it. So if I do this, there's Amsterdam because it starts with an A, but also contains an A somewhere inside of it. That one's an ends in A. You got the Hague with 2 A's. Almere starts with an A. This one's got 3 A's, but we don't care as long as it has a single A. Now, you can get a lot more precise with this by using the other control character, which is the underscore. So let's say I want 1, 2. So if I write it like this, it'll give me any city that starts with A that has a total of 6 characters in its name. Anything more than 6, anything less than 6 will be excluded. Cool trick. And then people go, well, what's the point of this one as opposed to match anything? Okay, let's just say you're trying to match postal codes. or phone numbers. Actually, phone numbers are even better as an example. Um, so unfortunately, I don't have the data in this database to demonstrate that, but let's say I want to show you using a phone number and I want to find everything that starts in 613. If I were to do that, I'd go select star from, I don't know, contacts, where phone, and assuming that they're storing the phone number with any special characters, um, or you always store it a specific way, you could go like um, 613, 1, 2, 3, 4, 5, 6, 7. And people would go, well, what's the point of just doing that match? That would mean it would find everything that starts in 613, but none of the phone numbers that have extensions. So, phone numbers are a little bit longer where you have like an extension number added on or whatever. This would also exclude international phone numbers because it would start with 613 and only be 7 digits long. Because when you call international, the phone number is longer than 14 digits because you got to put the country code. And of course, Canada and the US is the only one with a 1-digit country code. One. Europe, like for example, you call the UK, it's 44. Secondly, you throw a 44 in front of that. It's no longer 7 characters long. You could also do this to match postal codes. So I want to know everything that starts in with K. I don't care. C percent. So I would find any postal code that starts with K. I don't care what the digit is, but it also has to have a C. Not a very useful query, but it's things you can do with pattern matching. Um, there's a lot you can do with pattern matching once you start getting handy with it. You can use it to um, search for people's names where you don't know the entirety of their spelling of their name. Um, you want to find all the Dans, the Daniels, the Danielles, whatever. You could just go Dan percent sign, and it would give you every special spelling of Dan something or other. Would give you Danica and all the fun stuff to go with it, right? But it give you all the Dans. Okay, after the pattern matching, the next one is null. Have you guys been explained what a null is yet? Right, but have they explained to you what that actually is? Okay. They'll usually say it's a null value, but they don't actually tell you what null is. So null is the absence of value. So when you declare a variable, but it's never actually received a value, it's null. In other words, you've defined the box, but the inside is undetermined because there's nothing there. It's like a box, right? There's too much in the box, it's making sounds. But right now, pretend this box has been defined, this box exists, but we never put anything in it, ignore the rattle. There's nothing inside of it. Therefore, the box contains a null value. In other words, it's undefined, it's never received a value. Now, in most programming languages, they make it easier for you to work with nulls because they allow you to check if something's equal to null, right? What's the problem with checking if something's equal to null? It's impossible to equal null. There's no such thing because null is the absence of value, so you cannot be equal to the absence of value. Programming languages will just say equal to null. They make, equal null, just to make sure that you use the same syntax for everything. Now, the people who wrote the SQL language and created databases, they actually cared about the concept of null. They said, if we're going to do nulls properly, and we're going to create an operator for it. The operator is called is. Man, I really wish I could remember if one of these things has null values in it. Let me switch to this database is available to you guys somewhere. Uh, there, that works. So you can see right here that the destination airport ID in this table, for example, is null. Therefore, because something either is null or is not null. It's a Boolean operation saying, is it or is it not? It's not, is it equal to null? Because it's impossible for something to be equal to null. I wonder if they ever did that. See, actually, my editor's telling me I'm being stupid right now because I just highlighted that whole chunk. But if I try to run this, it returns nothing because it's impossible for something to be equal to null. Either it is or it is not. Um, which leads me to something kind of interesting, database concept-wise. Do I have time? Maybe, maybe not. Okay. Um, Database servers, I'll do it really quick. Database servers that support proper Booleans. MySQL and MariaDB don't support proper Booleans. You guys know what a Boolean is, right? True, false. So database servers like Oracle, Postgres, Microsoft SQL servers support proper Booleans. The cool thing is that unlike in programming languages where a Boolean is either true or false, Booleans in databases can be um, a, a three-state Boolean. Yes, no, I don't know. Because if it's null, if the Boolean is null, that means you don't know. So either yes, no, or I don't know. You have to program special for that in a programming language. The database server lets you say, we don't actually know the answer to this. So it's null. I don't know. So, cool tricks you can do with, basic database. All right, so I'm going to switch back to world. Use world. All right, now if star from, actually, no, I'm going to go, I just don't want to type everything again. Let me go grab this. Let's say I want to sort my results. I can go order by name, and it's going to sort my results by name. The default sort order is ascending, smallest to biggest. I can sort in the opposite direction by telling it to sort descending. And apparently ampersand S is the very last character. As you can see, it's not necessarily alphabetical sorting. It's sorting based on the character tables. You can sort by multiple items. Let's say I'm going to grab this again. Order by population, comma, country code. And this is going to give me first by population and then by country code. Or I could change it around to make it a little more sane and go. So it's sorting by country code and then by population. So it does two sorts. First, it sorts all the data, the first one by country, and then it does a subsort. So after it's figured out all the country code ones, so for example, here's Afghanistan. It sorts 1, 2, 3, 4 because it's sorted first by this, and then it does a second sort on that, so that's going ascending. You can sort by multiple columns. You comma delimit it. You can also mix match the sort order. So I want to sort by country code descending, but ascending population. And now we go ZWE, I'm guessing is Zimbabwe, and we're going smallest to biggest. There's all kinds of cute tricks you can do with your sort order. It's really handy. Or I want to go country and then smallest. So first by country code, then biggest to smallest. You can, like I said, you can mix match. Sometimes you'd want to return only a limited set of data coming back. Or the first 10 rows, right? The 10 biggest cities, that kind of thing. So what we can do is we can actually take this, let's go grab this query again, and I'm going to just sort by population. in descending order. And now it's going from the biggest city down to the smallest that's in this database. And we can say, hey, if we want to, we want just the top 5. The issue is that different database servers will do this differently. This is the SQL standard, but Microsoft SQL Server does it different. Oracle definitely does it different. Oracle's stuck in like 1986 when it comes to this. So here's a 5, which is cool. So of course you can mix match this stuff with um, your where clause. So this one will be, let's go grab this, um, where country code in and USA. Okay, I'm going to put this on 2 lines to make it easier to read. Okay, first things first, here's the top 5. But let's say I want to know what the biggest city is. New York. So instead of having to write code with Python or Java or PHP, whatever language you're writing in, figure this stuff out. You can get the database server to do it for you. Yes. A list, filter, sort, and then grab the biggest. And I had to write it, and I couldn't use any of the helper functions in PHP. It'd be probably, it's not a PHP, so I'd go probably 300 lines of code. This is the, the first one, the filter, the list, then the sort, then the everything. I could probably get it down to less than 50 lines of code if I really tried, but it's a lot of code. Or you could write one single SQL statement. And it gives us, the limit has one extra little parameter, which is cool. So when you go to a website and it shows you like 25 things and you hit next, then it shows you the next 25 things, you hit next, and you're paging through. It's using something called an offset. Offset allows you to skip rows from the beginning. So right now I say limit 1, but let's say I want to know the second biggest city. I can go offset 1, and then it'll give me the second one. And how do I know for a fact this is right? As if I were to leave the original one here with limit 5, New York, LA, Chicago, Houston, Philadelphia. So this one here is an offset 1. I could go offset 5, then it would give me the 6th. Yeah, you're skipping through the index. So essentially it's returning. So what this query does is it grabs those 3 columns from city, where it's in North America, sorted by population, biggest to small, and actually biggest to smallest because it's in descending order. We say we only want 1 row, but I want you to skip the first one. And yeah, and I finished just in time. Um, so this is a lot to absorb. And I realized that. There's a few things I did today that actually isn't in the slides. For example, offset isn't in the slides. And I don't remember if the Boolean one is in the slides or not. But it kind of fits together, so it's a good topic to have all in one place. But yeah, I'll have this posted to you guys, you know, probably by the middle of the next, actually I'll try to post it right at the start of the lab. And then, yeah, that's it. 49